Let me start with this one here, and it's called proactive fixups. The idea is we get much faster upgrades in CDB environments with many CDBs, and more CDBs here benefit the most from this new feature. What is it? It's a performance feature, so it's simply tailored to make upgrades run faster, and it basically changes only the order of certain tasks in auto upgrade. It isolates, in addition, errors in PDBs, and what I tell you now in the next 5 minutes is only valid for CDB upgrades. It does not apply to non-CDB upgrades. So this is a classic flow when we do auto upgrade. Auto upgrade creates a guaranteed restore point, pre-upgrade, pre-checks, pre-fixups, and then in the second line, DB upgrade, afterwards post-checks, post-fixups, post-upgrade. That's the standard, and it still is the standard for non-CDBs. No change here. But when we have a CDB environment with many PDBs, what happened in this workflow? At first, you saw the pre-fixups, standard. And once the pre-fixups were completed, then we entered the upgrade of CDB $root. Also, nothing changes here. But where we change now something, and it's this part. At standard, all the PDBs were now upgraded in certain groups. So group 1 was first, and group 2 was second, and so on and so forward. And once the groups were upgraded, then we could go on to the next step, post checks, and so on. So depending on when you had like one problematic PDB in here, which took much longer, it could delay the entire process significantly. Post checks then at the end. Now the new flow, you say, hey, wait a bit. This is the slide I saw before. And right, it's exactly the same slide you saw before. No change when we talk about CDB $root. Absolutely no change. But as we upgrade now PDBs here, after CDB $root has upgraded, we extend the process into the PDB upgrades. And here we do now a significant change. Here we have now the possibility to isolate upgrades, post checks, and post fixups on PDB levels. So we don't wait anymore. Let me show you what that means in the PDB upgrade stage. We start upgrading our 4 PDBs here, but one is finished, so it can go to the post checks and the fixups already. And you see, all can do this. So whenever a PDB is done, it can go to the next stage already. And when you look at the output about the stage progress, here in this output we created, you see that PDB $seed, the first one, is still in DB upgrade. It usually takes the longest of all PDBs. And some PDBs like PDB 1, 3, 4, and 5 are already in a fix-up phase, while PDB 2, 6, 7, 8, and 9 are still in the upgrade phase. And so it has another impact here. You see, when we take this now overall, we have 4 PDBs and root container and 4 cores. Fairly small environment. And ignore the first 4 lines. We look at the 5th line, the DB upgrade, 133 minutes versus 130 minutes on the right side with the new proactive fixups. But the really important line here is this one here, the post fixups. Since this ran in all 4 PDBs at the same time, especially the recompilation, that costs a lot of resources. While now, it just takes the resources available. And so our upgrade here decreased from 3 hours to a little bit more than 2 hours. That's a significant improvement. And another test here, 16 PDBs and root container, 8 cores, all the auto upgrade defaults used. No magic done, no hidden tuning parameters we don't tell you about. And again, we look only at the DB upgrade line and then at the post fixups line. So you see post fixups went down from 46 minutes to less than 1 minute, since a lot of the actions had happened asynchronously before and not all at the same time. This is a significant improvement again here of over 1 hour saved in the entire upgrade. And the more PDBs, obviously, the greater the impact, the greater the benefit is. If you have just 2, you won't see much benefit, a little bit maybe, but if you have like 200 or 150 PDBs, then you see a much, much bigger benefit from that feature.